So today we're incorporate numbers. But before we get there, is weight and mass the same thing? Weight and mass the same thing? No. I was told in junior high they were not the same thing. Is it possible to be in outer space and to be weightless? Is it possible to be in outer space and be massless? So you can be weightless, but it's impossible to be massless. What is another name for weight in physics? What's another name for weight in physics? Force of gravity. Okay. So force of gravity and weight are synonyms. No, not even synonyms. They're the same thing. Okay. Get to that? So looking at your units, what's the unit for force of gravity? What do we measure force of gravity in? Measure it in newtons. Mass, in chemistry, you measured it in what? Grams. In physics, we measure it in kilograms. Okay? Are weight and mass the same thing? No. But if you increase the mass, what happens to your weight? It increases. If you decrease your weight, what happens to your mass? It decreases. So they influence each other, right? But they're not the same thing. But there's a conversion factor that relates them. Does that make sense? Like, if I said, "Hey, you're 5 feet. How many inches are you?" Like, your conversion factor is 12. Okay, there's a conversion factor between weight and mass, and that is G. G is the absolute value of the acceleration of gravity. 9.8 meters per second squared. Not negative. Okay, this is the conversion factor to convert between kilograms and newtons. Okay. This equation can be used anytime or anywhere on or near the surface of the earth. This equation can be used anytime on or near the surface of the earth. So some people think, oh, I've got to be in free fall to use that because look, it's 9.8. No, this is not saying something's in free fall. This is just saying you're on or near the surface of the earth. You're essentially going to have this equation memorized, but because you're going to use it so much. Okay. Let's use it on you. Okay. We're going to figure out how many kilograms you are. So pull out your calculator. Take your pounds and divide them by 2.2. Take your pounds, divide by 2.2. That is your mass in kilograms. Okay? That could be encouraging or discouraging depending on how you want to go with things. Okay? That is your mass in kilograms. I want you to find your weight in newtons using that equation. We just found your mass in kilograms, taking your pounds divided by 2.2. So 2.2 is the conversion factor between pounds and kilograms. But I want you to use that equation to figure out your weight in newtons. That could be encouraging or discouraging, depending on how you want to go with things. Okay? So it should be in like the hundreds, maybe low thousand. Okay? Good with that? So again, this is the equation. If I give you kilograms and you're trying to find force of gravity, or I give you newtons and you're trying to find mass, this is the conversion factor between the two. You do not need to be in free fall. Okay? It's just G is just the number, it's a conversion factor. Okay? What is the unit for mass? What's the unit for mass? Kilograms. What's the unit for weight? Newtons. What's the unit for mass? Kilograms. What's the unit for weight? What about force of gravity? Force of gravity, newtons. Okay? All right. So today we're going to learn to convert between weight and mass. Check. Incorporate numbers into the free body diagram and solve problems. Check. Or no, not yet. Upcoming. And use free body diagram to compare the magnitudes of forces. We'll get there tomorrow. All right. You have a 60 kilogram crate at rest on a 32-degree incline. How much friction is present to keep it at rest? Now, oh my, has he taught us any of that stuff? I got two numbers. And friction. Ugh. Okay. Question. On your homework, how many numbers were used? None. You did not need any numbers to do what you did last night for homework or this morning for homework. Okay? I want you to employ the same technique when I do give you numbers. Don't touch the numbers until after you do the setup. Okay? So I'm going to give you like a 2-minute head start. I want you to do the setup, just the setup, steps 1 through 5. Free body diagram, positive direction, sum of the force to the x and y direction equal to 0 or not. Add up all the forces in x and y direction and set them equal to whatever they're equal. Go. Make sure we got step 1 going on. If you messed up that, it's going to be rough. Hopefully you've tilted the axis. I'm going to make down the ramp positive. You could have made up the ramp positive. It'll be fine because it's at rest. Some of the forces in the x and y direction are equal to 0. This is at rest. How'd we do? Grade yourself real fast. A, B, C, D, E, F. what you just did there was the majority of the physics. Okay? Let me just tell you what you just accomplished. Remember when we were learning kinematic equations? And you're like, so many equations, like there's 4 of them. And I have to like pick, which one do I pick? I don't know. But then after you practice, you got better at it, right? You got comfortable. Here, like what equation do I pick? You know what? You're making your own equations right now. What equations do I pick? Well, this one and this one. You just made your own equations for this specific scenario. Okay? And you didn't plug in any numbers. Okay? Once you have the setup, now you can plug in numbers. Don't touch the numbers until you have this setup. Okay? The biggest pitfall for this is to prematurely pick up a calculator and start trying to punch stuff out. Like, don't do it. Set it up. Even if you think you can do it without setting it up, I promise you there are such situations that are coming that I'm going to give you that you won't be able to do it without setting it up. There are just too many details. Okay? You need a plan. You need a roadmap. Okay? And this is it. All right? So let's start engaging in the numbers. Okay? So a 60 kilogram crate rests on a 32-degree incline. How much friction is present to keep it at rest? What are we ultimately trying to solve for? Friction. Where do we find friction? Right here. So if I can find FGX, I've solved the problem. Does that make sense? Okay. So I'm like, well, I've got 60 and 32. Probably going to incorporate that somewhere. Like, oh, I know. Can I take 60 and plug it into here? No, silly. Like, can I take 60 and plug it into here for force of gravity? Tell your neighbor. Why and why not? What's the unit on that? Kilograms. What is that? Mass. How do I find force of gravity from mass? Well, we just did it. Force of gravity is equal to mass times 9.8. Okay? So use that. We're gonna convert kilograms to newtons. So yeah, 60 kilograms times 9.8. And you get 588. Good there? We got something. It's gonna take 588. Stick that into here. Tell your neighbor why or why not. Okay. So this is that. This is 588. Think in your brain. Don't tell your neighbor yet. How are you going to find the blue side? Think in your head. Oh, sorry. Here's a preliminary question. This angle is 32 degrees. Okay. Is angle A, angle B, or angle C 32 degrees? Which angle is 32 degrees? It is always between the new y-axis and the force of gravity, B. That needs to be memorized. Okay? So this angle is 32 degrees. So now think, how are you going to solve for the blue side? Tell your neighbor. So we're going to use what? Sine of 32 is equal to FGX over the hypotenuse, 588. So I find that FGX is equal to we'll do 312. Now, can I take 312 and plug it into FGX? Yep. So 312 newtons is equal to force of friction. See how we did that? Please set it up. Okay. Questions there? Got a worksheet due on Thursday. You got some time. First hour got axed.